Hello, and welcome to the presentation of Ryerson Hill Quarry, Maine, Unusual Rutile Find. I am Lloyd W. Alexander, and I'll be your speaker today. My co-authors are Alexander U. Falster and William B. Simmons. Ryerson Hill Quarry is a complex pegmatite located in Paris, Maine, where you can see albite in the pegmatite, along with cross-cutting quartz veins and shoral patterns. Intrusions of the pegmatite into the country rock can also be seen as you look around at the quarry walls. And whereas it's been prospected and mined on occasion over the last 100 plus years, it is still virtually untouched. Looking at this picture of the quarry, we can see that it's 50 meters long from pit edge to pit edge and about 12 meters wide. The left quarry has been filled with overburden, and so I'm not sure how deep that one is. The right quarry is about 9 meters deep, and the study area is basically right in the middle. The geological survey was done in 1911 at Ryerson Hill. To this day, there remains a lot of unexplored pegmatite in a very rich area of the state, known for great finds. Ryerson Hill is surrounded by some of the most productive mines in Oxford County, including Mount Mica, which is about a mile away as a crow flies. In the years 2000 to 2003, Dick Dion had the mineral rights and added several new minerals, mainly phosphates that were previously undiscovered at Ryerson Hill. In the 2010s to the present day, Zoltan Matolsky, owner of the property, has been mining the pegmatite. He found a bathtub-sized pocket of smoky quartz and hydroxylherdorite. There have also been many satellite pockets of hydroxylherdorite in that area. The largest quartz crystal was 30 centimeters long by 15 centimeters wide by 20 centimeters deep. The largest hydroxylherdorite crystal was approximately 8 centimeters tall and 2 centimeters in diameter. In 2018, I began to collect material from the area between the two pits known as the bathtub. Several specimens were, and continue to be, brought to Al Foster at the MP² Research Lab at the Maine Mineral and Gem Museum, which is located in Bethel, Maine, for confirmation or in-depth analysis. The analysis is likely to produce additional new minerals for Ryerson Hill. Here we are able to see the original study area and the current study area. The original is in the orange, and that was 2.5 meters by 2.5 meters. The current one is roughly 8 meters long by 6 meters wide. The study area has pegmatite, schist, and gneiss. The pegmatite went from fine, small grains that are tightly packed on the top and has slowly transitioned to larger grains as progression was made down through the pegmatite. This is a slide that shows some progress that's been made as far as depth. In the beginning, we started out about 1 meter deep, and currently throughout the study area, it's 3 meters deep, with some variation depending on the exact spot. Here's an early shot of the study area, with Al and I looking at the pegmatite, deciding on the direction for exploration. The following mineral groups, minerals, and varieties of minerals have been found during the study, with many being new finds for Ryerson Hill. Additional new listings are expected as the ongoing study and analysis continues. The next few slides are other minerals that have been found at Ryerson. They are micro. Here we have columbite needles and bertrandite. In this slide, it's gypsum and parsetensite. Here we have chrysocolla and esophorite. We've also found plenty of childenite. In this slide, we have hydroxylherdorite and some of the albate shoral series, the clear rods and the brown rods. On this slide, you can see Ryerson Hill Quarry's relation to some of the other mines in the area and to the Songo and Sebago plutons. The significance of this will be examined further shortly. Finds of rutile turflite pods replaced by vivianite and albate shoral series are of note. Here is an image of the first albate to ever be found and documented at Ryerson Hill. It was found in February of 2019. It is 3 millimeters long in the indicolite variety. Since its first discovery, more albate shoral series have been found in an area roughly 7 meters long by 5 meters wide. In this area, the colors have been clear, brown, blue, and green. The area starts at a contact point with micaceous schist that quickly becomes albatized. As the area has proceeded away from the schist, the color of the albite has changed from the clear and brown to the blue and green. Crystals range from 3 millimeters to 15 millimeters. It has been associated with montmorillonite and muscovite in a few occurrences. The montmorillonite and muscovite occurrences are farther away from the contact point. The albite it is in has produced many of the minerals that have been found at Ryerson Hill and continues to be the focus of the study. As you can see, the albate shoral series thus far has been iron dominant. We are beginning to see a change in that, though, as we get further and further from the contact point. Dravite has been found in the schist near the contact point with the pegmatite. Here we have the clear and brown rods that have been found at the contact point and up to 1 meter away thus far. In this slide we have green albate in Muscovite. It was found furthest from the contact point and is beginning to show less iron dominance. Turflite vivianite pods have been found throughout the whole quarry, with the main concentration being from the edge of the left pit to the halfway point between the pits. The pods were in the pegmatite and not contacting any country rock. The pods show some replacement of turflite to vivianite has occurred, but remains iron dominant. The largest pods have been located from that halfway point and to the west in a roughly 4 meter long by 3 meter wide rectangle. The largest pod to date was 1 meter long by 0.5 meters wide by 0.02 meters deep. The turflite and vivianite pods are a pale blue on the outside with a much richer deep blue on the inside. Vivianite crystals have been found throughout the pods and are micro in size. Rutile was found in 2021 at Ryerson Hill and has been almost exclusively the sagenite aggregates. All the rutile has also been micro in size and in general ranging 1 to 3 millimeters wide by 1 to 3 millimeters long. The rutile has also been in association with microalbate shoral series rods that are clear to brownish in color. The rutile is also near a contact point with micaceous schist. Thus far, the rutile has been found in a small area about 3 centimeters from the contact and in a line about 1 meter long. Here's a slide we saw earlier, comparing the find of rutile at Songo Quarry to the one at Ryerson Hill Quarry is interesting. The Songo Quarry rutile is dark and blocky. The simulation of country rock in the rutile find at Ryerson Hill Quarry has provided the needed elements. You can see that the Songo Quarry sits in the Songo pluton. Ryerson Hill Quarry doesn't sit in either pluton. In these two ternaries, we see that niobium and iron are the dominant elements. The rutile has been fine needles and silver to gold in color. The country rock, biotite phlogopite, contains a titanium, sometimes over 1 weight%, that can be released during partial assimilation in pegmatite melt, thus making the find unusual for the area, as we have not seen any rutile in the anetetic pegmatites as of yet in the Oxford pegmatite. The image on the right is from Ryerson Hill, and you can see that the rutile there is very small but well defined. The picture on the left is from Songo Pond Quarry, and you can see that that's dark and blocky. In conclusion, Ryerson Hill Quarry is a pegmatitic zone that warrants further investigation. The 2018 ongoing study of Ryerson Hill has found many new minerals and variations. Tourmaline has been a significant find, with Mount Mica being approximately 1 mile away. The untouched nature of the pegmatite at Ryerson Hill signifies an opportunity to explore, to learn, and to discover. Further study and exploration will continue. Significant assistance and contribution by my co-authors, the MP² Research Lab, and the Maine Mineral and Gem Museum have been vital to this project. The Matulski family has also provided historical knowledge and guidance with the moving of material at the study site. Their help has been critical in moving things along.